A right triangle is a very special, specific kind of triangle, so we want to spend a minute to talk about its properties in particular. So we call it a right triangle because it includes a right angle or a 90-degree angle. So this would be an example of a right triangle, and the reason that we know it's a right triangle is because we have this little square here down in the corner, and remember that this square always indicates a 90-degree angle or a right angle. So we could say that this angle here is 90 degrees. It doesn't matter the measure of the other two angles. As long as we have a 90-degree angle, then we call it a right triangle. Once we know which angle is the 90-degree angle, then we can go ahead and label the three sides of the triangle, because the side that's opposite of the 90-degree angle is always called the hypotenuse of the triangle. That's the longest side of the triangle, always the one that's opposite the 90-degree angle. And then the other two sides are each a leg of the triangle. So we call these two sides the legs and this side the hypotenuse. So for instance, if this is triangle A, B, C, and we labeled the vertices or the corners of the triangle, then side AB is a leg, side AC is a leg, and side BC is the hypotenuse. Another really special property of right triangles is something called the Pythagorean theorem. The Pythagorean theorem is the equation a squared plus b squared equals c squared, and it only relates to right triangles. What it says is that if you call one leg side A and the other leg side B, and if you call the hypotenuse side C, the hypotenuse always has to be side C, then it's saying you square the length of this leg, so you get a squared, you square the length of this leg, which gives you b squared, and if you add those together, that's going to be equal to the square of the length of the hypotenuse, and this is always going to be true for right triangles. So this is going to help us find the side lengths of a right triangle, and it'll help us to find the perimeter of a right triangle. So let's take an example and say that we know that the length of side A is 3, that the length of side B, we'll say, is 4, and we're looking to find the length of the hypotenuse. Well, all we do is plug in the values of A and B to the Pythagorean theorem. So we say 3 squared plus 4 squared is equal to c squared. And then we simplify this equation. 3 squared is 9, 4 squared is 16, and 9 plus 16 is 25. So 25 equals c squared. Then we take the square root of both sides. So we say square root of both sides, and we do that so that we can solve for c, because the square root of c squared, the root and the squared cancel each other, leaving us with just c on the right-hand side. And then we say the square root of 25 is 5, so the length of side C, the length of the hypotenuse, must be equal to 5. So like we said, this theorem helps us answer all kinds of questions about the side lengths and the perimeter, because we could have been asked, if the length of side A is 3 and the length of side B is 4, find the length of side C, and we could have used the Pythagorean theorem to find the length as 5. Or we could have been asked, if the length of side A is 3 and the length of side B is 4, find the perimeter of the triangle. We would have gone through the Pythagorean theorem to find that the length of side C, the hypotenuse, is 5. And then to find the perimeter, we would have simply said the perimeter is equal to 3 plus 4 plus 5, the length of all three sides, which is 3 plus 4 is 7, 7 plus 5 is 12, and we could have said the perimeter is 12. So we can use this to answer all kinds of questions. One of the things that we want to say is that we found here that the length of the three sides of the right triangle were 3, 4, and 5. These values form together what's called a Pythagorean triple. So let's go ahead and just write down 3, 4, 5. This is called a Pythagorean triple because these three side lengths satisfy the Pythagorean theorem. They represent the two legs and then the hypotenuse. So any triangle with side lengths 3, 4, and 5 will be a right triangle. That's what we can conclude from that. And any multiple of a Pythagorean triple will satisfy the Pythagorean theorem and form a right triangle. So for instance, if we multiplied each of these side lengths by 2, so let's say we're forming a new triangle, and we multiply each of these sides by 2. 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. That means that the side lengths 6, 8, and 10 also form a right triangle because they also satisfy the Pythagorean theorem. The reason is that they still have the same ratio. We still have the same ratio between the side lengths with a 6, 8, 10 triangle as we do with a 3, 4, 5 triangle. So any multiple, if we were to multiply the 3, 4, 5 by 3, we would get 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. This is another Pythagorean triple that satisfies the Pythagorean theorem and forms a right triangle. Another Pythagorean triple is 5, 12, 13. You can test this out in the Pythagorean theorem and see that it's true. And so any multiple of this Pythagorean triple will also form a right triangle. So if we were to multiply this ratio by 2, 5 times 2 is 10, 12 times 2 is 24, and 13 times 2 is 26. So these would be the three sides of a right triangle. These would form a right triangle as well. The last thing we want to say about right triangles is that just like other triangles, the three interior angle measures of a right triangle sum to 180 degrees. And since you know that one of the interior angle measures is 90 degrees, 180 degrees minus 90 degrees is 90 degrees. So you know that these other two angles, the two non-90 degree angles, they together must sum to 90 degrees. So you have that 180 degree sum of the angle measures rule, just like with all other triangles. And you still have the rule where the area of the triangle is equal to 1/2 multiplied by the base multiplied by the height. Because you have side AB and side AC perpendicular to one another, they form a right angle. The legs are perpendicular. You can always use one leg for the base and the other leg for the height. It doesn't matter which way you set it. You could use this bottom here for the base and this vertical side for the height, or you could use this vertical side for the base and this bottom here for the height. Either way, multiplying those two together and then multiplying by 1/2 will always give you the area of the right triangle.